Alright, so this video we're going to look at inverse trig functions. Now this is probably going to be a long video, I'm guessing. I've got about 19-20 examples to work. But I think if you stay with me through the entire video, you'll get this stuff. And before we get started working examples, I want to spend some time on this right here. Okay? And get you to understand where this comes from. This negative pi over 2 to pi over 2, 0 to pi, negative pi over 2 to pi over 2. I think that's important that you understand why this is. Okay, and I think it'll make everything else easier on you. All right. So for x between negative 1 and 1, y equals the inverse sine of x, provided the sine of y equals x. So basically what you're doing is, what can we take the sine of? Okay? What can we take the sine of to get x? That's kind of how we're looking at it. And it'll make more sense when we start working the examples. And then same thing here for cosine and tangent. Okay? And for tangent, it's for any real number. For any real number, because we can take the inverse tangent of any number, but we can't for sine and cosine. X has to be between negative 1 and 1. All right, so let's look at this. Let's look at this a little more. So the best way for me to show you this is to draw you a graph and get you to understand this. So think back to when you were in algebra. All right, so there's a rough graph of sine. This would be 2 pi. This would be 3 pi over 2. This would be pi over 2. This is 0. This is negative pi over 2, pi. This would be, well, negative pi, and then negative 3 pi over 2, and negative 2 pi. All right, so we're talking about inverse functions. So if you remember from algebra, in order for a function to have an inverse, it has to be 1 to 1. Okay? And if you don't remember that, think back in algebra. Let's just look at a parabola. Okay? This is not a 1 to 1 function, because why? It fails the horizontal line test. Remember the vertical line test and the horizontal line test? The vertical line test, if you draw a vertical line through a graph and it intersects that graph in more than one spot, that means it's not a function. And then the horizontal line test, if you draw a horizontal line through a graph and it intersects that graph in more than one spot, that means it's not 1 to 1. And if it's not 1 to 1, that means it doesn't have an inverse. Okay? So you can see that this parabola here, this does not have an inverse because it's not 1 to 1. But if you remember, there were some problems on there that you probably had to find the inverse of something maybe like this. Okay? And then beside it, it would say for x greater than or equal to 0. So what did that do? For x greater than or equal to 0, that meant we only dealt with positive values of x. So that means that we would erase that part, and now it would become 1 to 1. We would restrict the domain to make it 1 to 1. Well, as you can see with sine, the graph of sine, it continues like this forever. Okay, both directions. And you can see if we draw a horizontal line through the graph, it's going to intersect it in a lot more than one spot. So it's not 1 to 1. But if we take this graph, and I know it's erasing the whole thing, but if we take this graph and we erase all of the graph except for this little piece right here that's between negative pi over 2 and pi over 2, you can see it's now 1 to 1. And of course, this is 1, and this down here is negative 1. Okay? So So you can see we restrict the domain to make it 1 to 1, and that's where this negative pi over 2 to pi over 2 comes from. All right? Now, yeah, I mean, we could have restricted the domain to this part of it or over here or wherever, but, it was just decided on that we're going to restrict it between negative pi over 2 and pi over 2. So what that means is anytime you take the inverse sine of something, you're going to get an answer between negative pi over 2 and pi over 2. Or if you were looking at it in degrees, between negative 90 and 90 degrees. Okay? So what that means is if we look at it, your solutions, see if we do this 0, pi over 2, and then look, this is, 270 or 3 pi over 2? But if we come this way, that's negative pi over 2. So you can see sine is going to be in the first or fourth quadrant. All right? And then look, there's a similar argument for cosine. You see that? There's a similar argument for cosine. So there's 2 pi, there's 3 pi over 2, pi over 2, 0, and then you got the negatives over here. That's negative pi, negative 2 pi, and then I'm not going to worry about doing the other ones. All right. Oh, okay. And then here's pi. All right. So if we're looking at this, this is not 1 to 1, but if we erase it and all we look at, there's 1, there's negative 1. If we look at it, like this, see, I've erased, see, there's cosine. But what am I doing? I'm erasing that and then everything over here also. So now that's 1 to 1. And so you can see we're just working from 0 to pi. And that's where that 0 to pi comes from. And then tangent is similar. So we know just the basic tangent function, when we graph it, would look like this. All right. And of course, tangent, it keeps repeating, right? It keeps going forever like this, both directions. But what we've done, and I'm not going to label the x-axis to the right and the left of this negative pi over 2 and pi over 2. But basically what we're doing is we're erasing this part of the graph and we're just focusing on this part from negative pi over 2 to pi over 2, and that's where this comes from. All right, now pay attention to what I'm doing right here with tangent, okay? Because this is really going to help you when it comes to cotangent. All right. So cotangent can be confusing, but if you'll just bear with me, all right, and I'll explain it when we get to cotangent. But right now, all I'm doing, I'm going over sine, cosine, and tangent. That's what we're looking at. We're going to do some secant, cosecant, and cotangent in a minute. All right. And if you notice that in the sine, it's less than or equal to, less than or equal to. That means it can equal negative pi over 2, and it can equal pi over 2, or negative 90 and 90. But with tangent, it can't, because see, tangent, you got your vertical asymptotes here at negative pi over 2 and pi over 2. Tangent's undefined at 90 degrees, or pi over 2 if you're in radians, okay? And I hope you understand pi over 2 radians, 90 degrees. It's the same thing. It's an angle measure. It's just one's in radians, one's in degrees. Okay? All right. So I hope that clears up where this comes from. All right. So when we take the inverse sine, we're going to get an angle measure between negative 90 and 90 degrees. And yes, we can get negative 90 and 90 as an answer. When we take the inverse sine of tangent, we're going to get an answer between negative 90 and 90 degrees, but they're not included. We can't get negative 90. We can't get 90 when we're doing inverse tangent. And then when we take the inverse cosine, we're going to get an answer between 0 and pi. All right, so keep in mind for inverse sine and tangent, we're going to be in the first and fourth quadrant. And then if I look at cosine, there's 0, there's pi over 2, and there's pi. So when we take the inverse cosine, I'm going to get an angle in the first or the second quadrant. Okay? All right, so now let's come down here and let's look at some examples. All right, so find the exact value. All right, now the one thing that you've also got to understand here is with these problems, they want us to find the exact value. So you have to know the sine, cosine, and tangent of 30, 45, and 60 degrees, and also 0, 90, 180, 270, and 360. You have to know those, the sine, cosine, and tangent of each one of these angles here. You've got to memorize those. And I wrote all these in degrees, but remember, that's also, if it was in radians, I mean, when you see 30 degrees, you should think pi over 6. Or when you see pi over 6, you should think 30 degrees. Okay? And then, of course, 0 degrees is just 0. This is pi over 2 in radians, pi. This is 3 pi over 2, and this is 2 pi in radians. Okay, I just wrote down their radian equivalent next to the degree measure. So we've got what? We've got inverse sine of 1/2. So the sine of what angle will give me 1/2? Well, that's 30 degrees. There's your answer. Okay, I'm going to do the first couple in degrees, and then we'll switch to radians. Okay, all right, what about the arc sine of negative square root of 3 over 2? All right, well, think about it. What can I take the sine of to get square root of 3 over 2? Just don't even worry about the negative right now. To get square root of 3 over 2. Well, that's what? 60 degrees, right? Let's do it in radians. That's pi over 3, right? Pi over 3. You see this negative here? So it's negative pi over 3. That's all it is. Okay? That's for sine. That's how it works for sine. And that's how it's going to work for tangent. Cosine's going to be a little different, and we'll get into that when we get to cosine. Okay? All right, what about arc sine of 0? Arc sine of 0. Well, students a lot of times will remember sine, cosine, and tangent of 30, 45, and 60. A lot of times what they have problems with is the 0, 90, 180, 270, and 360. That's what students tend to struggle with, memorizing those. But for the most part, students are pretty good at memorizing the sine, cosine, and tangent of 30, 45, and 60. So let's say we've got arc sine of 0. All right, so, we forget what that is. Well, what is it? Well, it's easy to do because we know how to graph the basic sine curve. There's 0, there's pi over 2, there's pi, there's 3 pi over 2, and here's 2 pi. Okay, there's 1, there's -1. So you can see sine is 0 here. It's 0 here and here. So what's our answer? Well, our answer is 0. I'll leave it in radians, 0 radians. Okay, it's 0. But you're sitting there thinking, oh, but wait a minute. Sine is also 0 at pi, and it's 0 at 2 pi. Yeah, you're right. That's true. But we're doing the inverse sine. Oh, and I did not mention arc sine, inverse sine. They mean the same thing. It's just a different way to write it. Okay? It's the same thing. So you might be thinking, pi, 2 pi, it's 0 there. Yes, that's true. But look, don't forget, our solution when we're doing the inverse sine has to be between negative pi over 2 and pi over 2. And you can see this is outside of pi over 2. And if we extended this on down like this, you see that? There's negative pi over 2 right there. And so in this little section here, whoop, not down that far. Let me write this over in another. See, remember, this is the only section we're looking at. So it's only 0 right here at 0. All right. All right, let's look at another one. What about inverse cosine of -1? All right, so this is another one where we could draw this out. See, there's cosine. There's pi. There's 3 pi over 2. There's 2 pi, pi over 2, and 0. But keep in mind, the only thing we're concerned with here is from 0 to pi, right? 0 to pi. So where's cosine -1? Well, remember, this is 1, this is -1. So you see here at -1, that's what? Pi. And so this is pi. And that's your answer. All right, what about the inverse cosine of square root of 2 over 2? Well, the cosine of what is square root of 2 over 2? 45 degrees, right? Pi over 4, that's one of the ones we memorize. All right, I'll go over a little bit at the end of the video with where we have to use a calculator. Okay, that's pretty simple because all we have to do is just plug it into the calculator. Now, that's one thing that you might be thinking of. Well, I can just plug all this into my calculator. Yeah, that's going to work on all of them except for cotangent. It's not going to work on cotangent all the time. It will sometimes, but not all the time. So hang around for that. All right, so what about this? Arc cosine or inverse cosine of -1/2. All right, so you've got to remember this up here, this right here. You've got to remember that. So cosine is between 0 and pi. All right, so if you think about this, okay, cosine is between 0 and pi, right? So it's here or here. So I'm looking for what is the cosine of what angle gives me -1/2. Well, I know cosine is positive in the first quadrant and it's negative in the second quadrant. So I know it's going to be over here in the second quadrant because it's a -1/2. All right. So what I want to do is I want to look at this and say, okay, the cosine of what is 1/2? The cosine of 60 degrees, right? The cosine of 60 is 1/2, positive 1/2. But I do have a negative, so I know I'm over here in the second. So I know I'm over here. Well, the cosine of 60 is positive 1/2. That's my reference angle, right? You see that? That's my reference angle. So what does this angle measure? Well, it's what? 180 minus 60, which is 120. And that's your answer. Or if I was in radians, that would be pi minus 60 is what? Pi over 3, which is 2 pi over 3. So, it's not two separate problems. I just did one, and I just did it in degrees, and I did it in radians, depending on what the directions say. If the directions say give your answer in degrees, then this is how you'll do it. If it says give your answer in radians, this is how you'll do it the second. Okay, so keep that in mind. That's what's so important about this, is knowing that up there that sine is between -pi over 2 and pi over 2. Also, inverse tangent is between -pi over 2 and pi over 2. And then cosine is between 0 and pi. Okay? All right. So now let's go to tangent. Now, what's tangent between? Or inverse tangent, what's inverse tangent? That's going to be between what? Negative pi over 2 and pi over 2, or negative 90 and 90. All right? All right, so let's look at this. So the tangent of what is positive 1? Well, that's 45 degrees, or pi over 4. Okay? What about this one? Arctan negative square root of 3. Well, the tangent of what is square root of 3? The tangent of 60 degrees, right? Well, let's write it in radians. That's what? 60 degrees is pi over 3. It's negative, right? Negative. So we put the negative in front. So do you see how when we did arctan of a negative and we did arcsine of a negative, we said, okay, what's the arcsine or arctangent of the positive? And then we just put the negative in front. That was all it is. That's for arcsine and arctangent. But on cosine, when we said, okay, the cosine of what is a positive 1/2? Well, we got that angle, and then we had to use that as a reference angle to find that second quadrant angle. And that is because cosine is between 0 and pi. So we had to get that second quadrant angle. It's not like inverse sine and inverse tangent. All right. Okay, so here we go. So that takes care of sine, cosine, and tangent. All right. Now what about secant, cosecant, and cotangent? All right, so for secant and cosecant, it's going to be the same thing. Secant, that's going to be the same as cosine. Cosecant, that's going to be the same as sine. All right, so those aren't going to be any different. But if you notice on your calculator, you don't have an inverse secant button on your calculator, okay? And we don't really know stuff about secant, cosecant, and cotangent. We don't really memorize the secant, cosecant, and cotangent of 30, 45, and 60. Okay, we don't really memorize those because we don't have to. Because, just real quick, we know the sine of 30 degrees is 1/2, right? So we know the cosecant of 30 degrees is 2 because cosecant is the reciprocal. So there's really no need to memorize those. But here we've got arcsecant of negative 1/2. Well, this is equal to what? Cosine. Now remember, secant and cosine are reciprocals of each other. So that's going to equal the cosine of negative 1/2. So we take the reciprocal of that negative 2. You see that? All right. Oh, it's cosine of a negative. So that tells us what? We know we're over here. Our angle is in the second quadrant, right? Because it's, I'm sorry. I don't know why I wrote cosine there. That's arc cosine. I know the cosine of an angle in the second quadrant is negative. Okay? So what's the arc cosine of positive 1/2? 60 degrees, or if we do it in radians, pi over 3. And so now we're looking for this angle right here. So that's going to be what? Pi minus pi over 3, which is 2 pi over 3. And there's your angle. Now, one thing that you might be saying is, oh, but wait a minute, cosine's also negative in the third quadrant, right? Yeah, cosine's negative in the third quadrant, but what did it say up there at the top? That y has to be between 0 and pi, so we're only dealing with the first two quadrants. Okay. All right, let's look at cosecant. So it's going to be the same rules apply for cosecant as it does sine. So we've got arcsine of 3 over 2 square root of 3. And then I rationalize the denominator. And so that's going to be inverse sine of 3 square root of 3 over 2 times 3. Just multiply numerator and denominator by square root of 3. And so that's going to be inverse sine of the 3's cancel of square root of 3 over 2. So the inverse sine of square root of 3 over 2, well, the sine of what is square root of 3 over 2? That would be 60 degrees, right? Or if we put that in radians, that would be pi over 3. All right. So that goes for secant and cosecant. All you do for, well, arc inverse secant, inverse cosecant, all you do is you just change it to inverse cosine or inverse sine of the reciprocal of whatever these numbers are. And then you do it like you did before. Okay? You do it like you did before. What we did was sine and cosine up above. Okay? All right, now let's get down here to cotangent. Okay, so I got 2 problems of cotangent. All right, so this is going to be inverse tangent of square root of 3. Okay? And before we get started here, let's look at this a minute. I mean, the answer is the tangent of what is square root of 3? The tangent of 60. So that would be what? Pi over 3. That's your answer. No problem there. Okay? And just reciprocal of this, and then do it like we did, change it to inverse tangent of the reciprocal of this, and then do it like we did before with the tangent function. Now let's come over here. We've got inverse tangent of negative 1 over square root of 3, which is inverse tangent of negative square root of 3 over 3 after I rationalize the denominator. All right. So what you might think here is the tangent of what is 30 degrees. I mean, the tangent of what is square root of 3 over 3? 30 degrees, which is pi over 6. Okay? If you're taking notes, don't write this down just yet. And so you might think, well, that's negative pi over 6. And if you do that, you would be wrong. Okay? You would be wrong. And let me show you why. So you remember up here when I went over this right here with the graphs, okay, and showed you how we restrict the domain. So keep in mind what we've got here with tangent, negative pi over 2 to pi over 2. All right, now let's look at this. What's the basic graph of cotangent? That looks like that, right? And it just keeps going. Like if we kept going, we would be here at 2 pi, and it would do like this, and then, there's a vertical asymptote there, and then it would look like this also, okay? But we have to do what? We have to restrict it. So we're going to erase this, and we're going to erase this, okay? Now, remember, when we did tangent, just real quick, let me write it down again. Pi over 2, negative pi over 2, and that was tangent, right? See, we were restricted here between negative pi over 2 and pi over 2. But look at cotangent. It's between 0 and pi. It's kind of like cosine now, right? You see that? You see how tangent and cotangent is positive in the first quadrant, positive in the first quadrant, negative in the second. This is a negative. You see that negative? Well, the negative here, that means we're in the second quadrant for cotangent because of this right here, because we're between 0 and pi. You see that? So what do I have to do here? Well, I know I'm in the second quadrant, right? So we're here. I know we're looking at tangent right here, but our original problem is cotangent. All right. So the tangent of what is positive square root of 3 over 3? 30 degrees, or what? Pi over 6. So what is this angle in the second quadrant? It would be pi minus pi over 6, which is 5 pi over 6. And there's your answer. All right. So sine, cosecant, you do them the same. Cosine, secant, you do those the same. And when I say sine, cosecant, cosine, secant, I mean inverses. Okay. Inverse sine, inverse cosecant are done the same. Inverse cosine, inverse secant, those are work the same. All right. You just, for cosecant and for inverse cosecant and inverse secant, you're just doing the reciprocals and then doing inverse sine, inverse cosine. But tangent, inverse cotangent, they're not done the same. Okay. You're going to have to do the inverse cotangent. You're going to have to change it to inverse tangent and do the reciprocal. But then when we go to find the angle, you can see it's worked like we did inverse cosine, because we're between 0 and pi, just like with cosine or inverse cosine. All right. So I hope that clears it up. And that also takes me back to when you're doing a calculator. If somebody gave you something like this in a calculator, you would have to do the reciprocal, but your calculator would not give you the right answer. If you worked this problem in your calculator and you punched all this into your calculator would give you that as an answer. And that's not right. Because in your calculator, you're doing the inverse tangent of a negative. So it's going to give you based on the inverse tangent, which is negative pi over 2. But you've got to be able to understand this and say, oh, but I'm doing inverse cotangent. So it's here. And so I've got to use the pi over 6 as a reference angle to get that second quadrant angle. So be real careful with that. Okay. All right, let's look at these. All right, so how about this one? The sine of the inverse tangent of 0. All right, so this is easy. It's no problem. Look at this. You just work inside the parentheses first. All right, so this is equal to what? What's the inverse tangent of 0? 0. And then what's the sine of 0? 0. That's all it is. Okay? Same thing here. This is what? Arc sine. What's the cosecant of pi over 6? Pi over 6 is what? 30 degrees. What's the cosine of 30? Square root of 3 over 2. And so, what's the inverse sine of square root of 3 over 2? The sine of what is square root of 3 over 2? 60 degrees? Or what? Pi over 3, if we're in radians. And that's all it is. You just work on inside the parentheses and just kind of work your way out. That's all you're doing. Okay. Now how about this one? The tangent of inverse secant square root of 2 over 2. All right, so let's look. So that's tangent. And so that's going to be what? Inverse cosine of 1 over square root of 2, which is equal to the tangent of inverse cosine of square root of 2 over 2 after I rationalize the denominator. All right. So what's the inverse cosine of square root of 2 over 2? Well, the cosine of 45 is square root of 2 over 2, right? So that's pi over 4. I'm just going to do everything. I'm going to do everything in radians, okay? So the tangent of pi over 4 is what? Well, that's 1. See, it's like I'm working two problems in one. I'm working inside the parentheses, getting that answer, and then I'm working the rest of the problem. All right, so how about this one? What about this one? The inverse sine of sine of pi over 6. All right, so work inside the parentheses. Well, what's the sine of pi over 6? Pi over 6 is what, 30 degrees? So the sine of 30 is what? 1/2. And then what's the inverse sine of 1/2? 30 degrees, or pi over 6. All right. Now, make sure here on this one, make sure that you don't look at this as, oh, I'm just canceling those out and getting my answer. Don't think like that, okay? Don't think like that. Because if you thought like that, then what would be the answer to 17? 2 pi over 3? That's not right. Okay? So, let's look. Let's see what we have. So this is the inverse sine of sine of 2 pi over 3. Well, we don't remember the sine of 2 pi over 3. We know the sine of 30, 45, 60. Or pi over 6, pi over 4, and pi over 3. We know the sine, cosine, and tangent of that. And I know if you've watched my videos, you have heard me say that a lot. Because it's that important that you memorize those. Okay? I'll put it to you this way. If you're watching this video and you're lost on how I'm getting the pi over 4 here and the 1 here, or if you're lost of how I got the 1/2 and then the pi over 6, if you're lost on that, then that means you don't have those memorized and you need to go memorize those. Okay? I'm telling you, you've got to memorize them. So here, I need to figure out what the sine of 2 pi over 3 is. Well, 2 pi over 3 is right here in the second quadrant. So remember finding exact values using reference angles. Okay? So what's my reference angle? Well, my reference angle is what? Pi minus 2 pi over 3, which that is pi over 3. So the sine of pi over 3, what's the sine of pi over 3? That's the sine of 60. That's what? Square root of 3 over 2. And then, so that's going to give you the value. The reference angle is going to give you the value. Then, I'm in the second quadrant. Is sine positive or negative? It's positive. So it's just square root of 3 over 2. And so the sine of what is square root of 3 over 2? The sine of 60. Or if we're in radians, pi over 3. So there's your answer. So what I'm getting at is you can't just look at this and say, oh, well, those cancel. Okay? You can't do that. Don't do that. All right, let's look at this one. Like I said, work with the inside and work your way out. All right, so we've got inverse cosine of, now I've got to figure out cosine of negative pi over 3. I've got to figure out what that is. Okay, so this goes back to the beginning of your trig class when you were finding the exact value. Okay, finding the exact value. I don't know the sine, cosine, and tangent of these negative angles. But do you remember coterminal angles? Okay, so let's take the negative pi over 3 and add 2 pi because we want to get it back between 0 and 2 pi. And so what is that going to be? That's going to be 6. That's going to be what? 5 pi over 3. All right. So just remember, all I'm doing right now is I'm just working this part on the inside. So 5 pi over 3, what is that? Let's see, 5. All right, so that's in the fourth quadrant here. See, there's 5 pi over 3. here's my reference angle. So my reference angle is 2 pi minus 5 pi over 3, which that's going to be pi over 3. There's my reference angle. So the cosine of pi over 3, or the cosine of 60, is what? 1/2, right? That's going to, my reference angle is going to give me the value. And then I've got to see what quadrant I'm in to see if it's positive or negative. Well, I'm in the 4th quadrant. Cosine is positive in the 4th quadrant, so it's positive 1/2. And then the cosine of what gives me 1/2? The cosine of 60 degrees. Or if we do it in radians, pi over 6. And so there's your answer. So just remember, all you're doing is working on the inside, getting that answer, and then working the rest of the problem. All right, now let's look at this one. Oh, goodness. Now this one, the sine of inverse tangent of 3/4. All right, so 3/4, that's not a number that we recognize. 3/4 isn't anything we recognize. So for this one, you might think, well, just plug it in your calculator, put it into your calculator. Well, that would be nice. But, and I know this was a long time ago, but the directions say find the exact answer. The directions tell us to find the exact answer. And when the directions tell us to find the exact answer, what does that mean? That means no calculator. So what in the world do we do with this problem? This is one where we skip it and go to the next problem, right? No, we work it. All right, so here's how you work these. So let theta equal inverse tangent of 3/4. So this means tangent theta equals 3/4. All right. How did I get that? How did I get that? Okay, for one, I'm just saying, okay, let theta equal this. I could use x, I could use alpha, I could use beta, whatever. Okay, I just picked theta and said let theta equal what's inside those parentheses. Remember, we're working with what's inside the parentheses first. All right, so how in the world did I get tangent theta equals 3/4? Well, let's scroll all the way back up here to the top. That this, you see that? See, I said let theta equal inverse tangent of 3/4. That's what I said. So now if I go to this part of it, then that means, see, the tangent of this, so the tangent of theta equals 3/4. That's where that comes from. All right. All right, now let's go all the way back down here again. All right, so here we are. So now let's solve it. So we're going to plot this. We've got a triangle, don't we? Isn't tangent y over x? So there's x, there's y, right? That's x equal, and this is y equals, and I can get r. That's just a what? A 3, 4, 5 triangle, right? So we know that's 5. Go ahead and do it. R squared is 3 squared plus 4 squared. So r squared is, what's that? 9 plus 16 is 25. So r is 5. That's where it comes from. Okay. And this is my angle theta right here. All right. Everybody good with that? All right. I can't believe I sat there and asked y'all if y'all were good with that. Like I can get responses from y'all. All right. So we've got sine inverse tangent of 3/4 is equal to sine theta. Right? How did I get that? See this inverse tangent 3/4, inverse tangent 3/4. What is inverse tangent 3/4? It's theta. See, I just replaced that with theta. So the sine of theta, see there's our angle theta. Theta is what? Oh, y over r, or opposite over hypotenuse. So that's equal to 3/5. No, excuse me. That's equal to 3/5. That's my answer. Okay. All right. Now, as I promised, at the end I would explain some calculator stuff. Honestly, there's really nothing to explain for inverse sine, inverse cosine, inverse tangent. Just punch it in your calculator. Calculator's going to give you the answer. If you have inverse cosecant of say 0.25, something like that, well, just remember you've got to rewrite that as inverse sine of 1 over 0.25. I'm sorry, I don't know why I wrote that. That can't happen. That was kind of stupid, wasn't it? You can't take the inverse cosecant. Can't take the inverse cosecant of a number between -1 and 1. So this would be 1 over what? 1.25. So then you would just punch it in your calculator and get the answer. So the one I want to talk about is inverse cotangent of say, I don't know, 1.3. Well, that's the inverse tangent of 1 over 1.3. So if I punch that into my calculator, and I'm going to be in degree mode. So I've got inverse tan of 1 divided by 1.3, and that gives me 37 point, I'll round to 1 decimal, 37.6 degrees. Okay, that's fine. So everything you do, you can do in your calculator. Just punch it in. For inverse cosecant, inverse cotangent, inverse secant, you've got to change it, to inverse sine, inverse cosine, or inverse tangent by doing the reciprocal, and then punch it in your calculator. Everything's fine. Everything works. So now the one that doesn't. So that is if you are doing the inverse cotangent of say -0.78. Okay, so first thing we would do, that would be the inverse tangent of -1 over 0.78. Okay, so now I know, because I'm doing the inverse cotangent of a negative number, I know I'm in the second quadrant, because remember, cotangent is between 0 and pi, like cosine. Okay, so the inverse tangent here, well, I'm going to do the inverse tangent of positive 1 divided by 0.78. And that is, when I do the inverse tangent of positive 1 over 0.78, that gives me 52.04576912 degrees. But I'm just going to round it to 52 degrees. Okay, and so now I need to get this. So this is going to be 180 minus, and then I've got what? 52, which that's 180 minus 52. That is 128 degrees. And actually, I really shouldn't put an equal sign there, because this does not equal this. Okay, and so it really shouldn't be an equal sign. There's actually a formula that they put in the books, that it says that if you have the inverse cotangent of x, that is equal to the inverse tangent of 1 over x plus pi, and that's when x is less than 0. Okay? There's this formula. So this is actually equal to plus pi, if you do that plus pi. And what they're doing is they're doing it for you. They're saying, okay. They're saying, okay, so when you do the inverse cotangent and x is negative, so this term here is negative, you do the inverse tangent of the reciprocal and then add the pi. All right? So that's your formula for it. So if you remember that, by all means, do that. But what I'm doing, the way I'm working these, is I'm not using this formula here because I want you to understand what's going on. So you can see, so if you look at this, okay, so let's just look at this. Now, keep in mind we're in degrees, so let's just change this to 180, okay? And so if I come up here and I do the inverse tangent of this, right, the inverse tangent, that gives me 52 degrees plus the 180. You see that? Well, I'm sorry, negative 52, because if I punch this into my calculator, the inverse tangent of negative 1 over 0.78, that's going to give me negative 52 degrees plus the 180, which that's going to give me my 128 degrees. All right? Isn't that all I have here? See my negative 52 plus 180? That's all it is. But now you know why that plus 180 is there, or that plus pi is there. You know why it's there now. Okay? So, you know, I went through all that and showed you, yeah, this complicated way to do it, I guess you could say. Now, do you have to keep doing it like this and drawing this out? No. You can just use this formula right here. But now you understand why the formula is like it is. And if you do forget the formula, you can always do that. Do what I've been showing you. Okay? All right, so I hope this helped. Check out my other videos. Don't make this stuff more complicated than what it is. It's not bad. And also, and I don't know if anybody's still watching this. If you are, good. I'm glad you're still watching. I've got some videos. If you Google my channel for inverse trig functions, I got 4 videos on inverse trig functions. It's a lot. It's more examples. So if you want to watch that and check those out, or if you want to go to that video and, you know, you play the video when it comes to the problem, pause the video and you work it and then play it, try that. Okay? All right, so I hope this helped. Give me a like, share, and subscribe. Thanks for watching, and I'll see you later.